Hello everyone, I will introduce and show the experiment or comparison between inlet get-Vane control and variable fan speed control to you via this video. This experiment mainly has 4 aims. Firstly, you can become familiar with the two methods of VAV control by adjusting the inlet get-Vane position or by varying rotational speed of the fan. Secondly, you can familiarize with the technique and the instruments for power consumption and efficiency measurement on the fan, and the associated control equipment in a VAV system. Thirdly, compare the relative energy saving capacity of each control method. Last one is you can appreciate the operating limits of each control method. Inlet get-Vane control and variable speed control are the two most widely adopted methods of supply flow rate control in VAV systems. Although the latter method is more expensive, it can save more fan power than the former. Based on the fan law, the power consumption is proportional to the cube of the flow rate. So, when the flow rate is reduced to half of the rated flow rate, the power consumption should be just 1/8 of the rated power consumption. However, the achievable fan power saving in practice is significantly less than this theoretical prediction, particularly when duct static pressure is used as the controlled variable. The power saving is still greater than the conventional inlet get-Vane control. In this experiment, the fan power reduction characteristics of the two methods will be measured and compared, and the fan efficiency under reduced flow conditions will be assessed. Now, let's move on to the experiment equipment. In this experiment, the Usher standard fan test rig will be used, as shown in this picture. Then, look at this photo. This is the experimental setup for our experiments. According to this photo, I will introduce the equipment and the instruments in detail. The rightmost side of the test unit is the inlet get-Vane. We can manually adjust its opening position, and these are pictures of its fully open and fully closed status. Next is the variable speed centrifugal fan, and this is centrifugal fan's frequency controller. We can use it to adjust the speed of the fan. On the right is the display of electrical energy meter. We can directly read the voltage, the current, and the power consumption. This manometer is used to measure the pressure on port 1. And port 1 is in this position as shown in these pictures. The manometers next to it are used to measure the pressure on port 4 and the pressure difference between port 3 and port 4. There are 3 identical nozzles at this position in the duct. To the left is the axial fan and its frequency controller. The leftmost part of the test unit is a discharge damper. We can also manually adjust its opening position. These are pictures of its fully open and fully closed status. These are all the experimental equipment and instruments. Now, let's move on to the experimental procedures. In stage 1, please familiarize yourself with the fan test rig first. Step 2, properly connect the manometers. Next, set the inlet gate vane and the discharge damper to their fully open positions. Properly connect the motors of the centrifugal and axial fans to their frequency power supply units, and mount the electrical energy meter. The last step in stage 1, ask the supervisor to check the electrical and pressure measurement connections before switching on the power supply. The first step in stage 2, switch on the power supply to the centrifugal fan and adjust the frequency of electricity supply to 50 Hz. After a while, switch on the axial fan and adjust its frequency to 35 Hz. When the fans are running steadily, note the static pressure at port 4. Then, adjust the discharge damper position such that 250 par increases the static pressure at port 4. The resultant static pressure value at port 4 is to be taken as the control set point for the centrifugal fan. Next, measure the power consumption of the centrifugal fan and take pressure readings P1 and P for determination of airflow rate and fan pressure. The next step is to reduce the frequency supply to the axial fan by 10 Hz. When the system achieves steady operation, note the pressure reading at port 4. After that, adjust the inlet gate vane such that the pressure at port 4 is brought back to its constant controlled static value. Next, repeat steps 2.3 to 2.5 three times, but with the frequency of the axial fan reduced by about 5 Hz each time. In stage 3, reset the inlet gate vane of the centrifugal fan to fully open. Then, repeat the procedures of test number 1, but instead of adjusting the inlet gate vane, the speed of the centrifugal fan is to be adjusted to maintain a constant controlled static pressure at port 4. Let me show you the experimental data. This is the experimental data of test number 1. This is the experimental data of the test number 2. You can use this formula to calculate the air volume flow rate. That's all the introduction and the display of the experiment. Next, please finish the logbook report and formal report. Thank you for your watching.